फोर्थ पॉइंट है, if the multiple bond and the some other substituent are present in the ring, then the numbering is done in such a way that the multiple bond gets the lowest number. Fifth point है, if the functional group is present along with some other substituent in the ring, then the functional group gets the lowest number. If both rings as and the side chain contain functional groups, then the side chain or ring containing principal functional group will act as principal chain. If, however, the alicyclic ring and the side chain contain the same functional group, then side chain or the ring containing more number of carbon atom will act as principal chain. Seventh point है, if an alicyclic ring is directly attached to the benzene ring, then it is named as a derivative of benzene. Eighth point है, if the ring contains functional group which has carbon atom directly attached to the ring, then carbon atom of functional group is not considered in numbering. Ninth point है, if there are more than one functional group attached on the ring, then one of the group is considered as parent and other is named as substituent. 10th point है, IPAC naming of bicycle cycloalkanes. The hydrocarbons and their derivatives contain two or more rings are called bicyclic cycloalkanes. The carbon atom common to both the rings are called bridgehead atoms, and each bond or chain of carbon atom connecting both the bridgehead atoms is called a bridge. The bridge may contain 0, 1, 2, etc. carbon atoms. Examples हैं, the bicyclic compound are named as A. Find the name of alkane by counting the total number of carbon atom as in the two rings. B. Add the prefix bicyclo before the name of the hydrocarbon. C. Find the number of carbon atoms in each of these three bridges connecting the two bridgehead carbon atom and indicating by Arabic numerals, that is 0, 1, 2, etc. Now arrange these Arabic numerals in descending order and separated from one another by full stops and enclosed in square brackets, and place these bracketed Arabic numerals between name of alkane and prefix bicyclo. If a substituent is present, atoms of the bicyclic ring are numbered. The numbering begins with one of the bridgehead atom. Proceed first along the longest bridge to the second bridgehead atom. Continues along the next longest to the first bridgehead and is finally completed along the shortest path. फिर है methods of preparation of cycloalkanes and their derivatives. The important method for preparation of cycloalkanes and their derivatives are discussed below. Number 1. Prune's method. Dehalogenation of dihalogen derivative of alkanes. When 1, 3 or 1, 4 etc. Dihalogen derivative of alkane, that is dihalogen compounds with halogen at terminal carbon atom react with metal, sodium or zinc. They get dehalogenated to form cycloalkanes. For example, when 1,3-dibromopropane react with metallic zinc, cyclopropane is formed. When 1,4-dibromobutane reacts with metallic zinc, cyclobutane is formed. Note: Number 1. This method gives good yield only for the preparation of cyclopropane. Number 2. If terminal halide is present at 1,5 or 1,6 carbon, then reaction forms open chain alkanes. 3. This reaction is comparable to internal Wood reaction. 4. The reaction proceeds through the formation of free radical followed by cyclization to form cycloalkane. Mechanism: 1,3-dibromopropane to cyclopropane. Number 2. Dykman condensation. It is important. It is an intramolecular condensation which occurs in esters of certain dicarboxylic acid such as adipic acid, pimlic acid. When ethyl adipate is treated with sodium ethoxide, cyclic beta ketoesters 2-carboethoxycyclopentanone is formed, which on hydrolysis followed by decarboxylation forms cyclopentanone. The ketone then on reaction with zinc amalgam HCl undergoes Clemson reduction to give cyclic alkenes. When diethyl pimelate is treated with sodium dust or sodium alkoxide, it undergoes intermolecular Clemson condensation Dykman reaction to form cyclobeta ketoester. The cyclic beta ketoester on hydrolysis followed by decarboxylation yield cyclic ketones, which on reduction with zinc amalgam and concentration HCl Clemson reduction forms cycloalkane. Mechanism. The reaction occurs through following steps. Number 1. Abstraction of alpha hydrogen by the base to yield carbanion, followed by internal condensation to yield 2-carbethoxycyclohexanone. Hydrolysis of 2-carboethoxycyclohexanone to 2-carboxycyclohexanone followed by its decarboxylation or to yield cyclohexanone. 3. Reduction of cyclohexanone to cyclohexane, Clemson reduction. Third point. Pyrolysis of calcium and barium salt of dicarboxylic acid, Wislicenus method. Calcium, barium or thorium salts of dicarboxylic acid on heating strongly form cyclic ketones, which can be reduced either by Clemson reduction or Wolff-Kishner reduction to cycloalkanes. Wislicenus method for formation of cycloalkanes is based on blank rules according to which 1. Number 1. 1,3-dicarboxylic acid, geminal dicarboxylic acid, in which both carboxylic acid groups are attached to same carbon atom. On heating, undergo decarboxylation to form monocarboxylic acids. 2. 1,4 and 1,5 dicarboxylic acid on heating or distillation in the presence of acetic anhydride give cyclic anhydride. 3. 1,6 and 1,7 dicarboxylic acid on heating or upon distillation with acetic anhydride give cyclic ketones. 4. 1,8 and higher dicarboxylic acid remain unaffected on heating. 4th. Demjanov rearrangement. This method provides a pathway for expansion and contraction of cyclic compound and involves formation of carbocation as intermediate. The carbocations formed may show any of the following reactions. Number 1. Substitution reaction. Number 2. Elimination. Number 3. Wagner-Meerwein rearrangement, that is rearrangement to form more stable carbocation through 1,2-hydride or 1,2-alkyl shift. Example involving ring expansion and ring contraction, that is Demjanov rearrangement, are discussed below. Ring expansion. When cyclobutyl methanol is treated with concentric H2SO4 at 443 Kelvin, we get three products. Product 1 and 2 are formed through ring expansion, whereas product 3 is formed without undergoing ring Expansion. Ring expansion. When cyclobutyl methanol ring contraction. Dimension of rearrangement occurs through ring contraction when the carbocation intermediate has positive charge on the alicyclic carbon. For example, number 1. Cyclobutanol undergoes dehydration at 443 Kelvin to give cyclobut 1-ene as normal product and 1 cyclopropyl methanol through ring contraction. Number 2. Cyclopentylamine oil treated with nitrous acid undergo deamination to form cyclopentyl carbocation, which forms cyclopentyl alcohol as normal product and cyclobutyl carbinol and methylene cyclobutane through ring contraction. Number 5. Addition of carbenes methylene to olefins. When an alkene is treated with diazomethane in presence of ultraviolet light, photolysis of diazomethane occurs to form methylene, which adds to alkene to give cyclopropane derivative. Diazomethane exists in contributing forms. Photolysis of diazomethane. Methylene formed by the photolysis of diazomethane is of two types. Singlet methylene. It is formed in liquid phase photolysis. In singlet carbene, the two non-bonding electrons are of opposite spins. B. Triplet methylene. It is formed in gas phase photolysis. In this type, non-bonding electrons are present in different orbitals. It is also called a biradical. The addition of methylene, the doubt bond, is in accordance with the scale theory, according to which singlet methylene reacts by one-step mechanism and addition is stereospecific in nature and stereochemistry of the alkene is retained in the product. For example,